Well, hello, everybody. I hope you're not too hungry. Hopefully, the information that I'll give you will give you a better idea of the environmental situation that we're looking at. So maybe some of you know, maybe others of you don't. In soils and the microbial communities that live inside soils actually provide us with very many free services. And this is a very good thing given the current economic crisis. No? Some examples of these free services that we get from soil bacteria include water filtration, waste disposal, and plant fertilizer. Unfortunately, we have dumped quite a big number of substances in the environment that actually threaten the health of these communities. And my job as an environmental engineer is to try to protect them. Now, the substances that we put into the environment are already there, and we can't actually go back and remove them. But one thing that we can do is try to control their spread so that other communities that are not affected continue to be decimated. The substances that I'm talking about are particles, and you can kind of think of their behavior to be a little bit like a barbaric. When they're contained, you can mitigate the damage that they do. But if you release them, open the gates and let them go wild, they go from community to community pillaging. In soils, changing the pH and changing the ionic strength of the water, as well as changing the flow at which the water flows, is a little bit like opening the gates for these pillagers. So what we're trying to do is understand some of these environmental effects that essentially do this gate opening for the microbial contaminants. And we're trying to do this in order to, first of all, identify the concrete events that cause this, but more importantly, to quantify how open these gates are in case any of these events actually occur. The way that we're doing this is by looking at processes that happen inside a soil. And as you might imagine, it's very, very difficult to actually look inside a soil because it's opaque. So the neat thing that we've been doing is we created a transparent soil that actually allows us to literally see right through it. It allows us to optically access all the pores within the system. And with a set of cameras, we can actually spy on these particles. And we can measure where, how quickly, and when these particles move through the soil, when they get stuck, and when they get released, every time that we apply one of the changes that I just mentioned that open the gates. Now, the main outcome for the work that we're doing is to be able to pinpoint the worst set of conditions that open the gates for these contaminants to move around and affect different communities in the soil. But the ultimate goal is to be able to use this information to inform land management strategists about the conditions that they should regulate in order to actually try to keep these gates as tightly shut as possible. I'd like to thank you for your attention and take any questions.